Hi everyone, welcome to the UW-Geology Museum Open House. My name is Aaron Kufner. I'm a graduate student here at UW-Madison, and I'm here in the UW-Geology Museum Prep Lab to show you some of the things I've been working on and how it relates to other things that we have in both this museum as well as the zoology department across the street. So, what I work on are these animals called temnospondyls. Now you might be thinking, whoa, what is a temnospondyle? You gotta tell me this stuff. So a temnospondyl is an amphibian. So if you think of like modern frogs, salamanders, and if you know of these limbless amphibians called caecilians, those are probably all temnospondyls. At least that's the prevailing idea. There's still ongoing research to figure out exactly where those animals come from the like known fossil animals. Almost certainly frogs and salamanders are temnospondyls, but caecilians kind of throw us for a loop because they're super weird. They're very, very derived in a lot of their features. But the name temnospondyl comes from two words. So temno means to cut, and spondyle refers to vertebrae. So that means that their vertebrae are in different pieces. They're kind of cut up into different chunks. And those different parts come together and make what we call a vertebra. Now, it's a little bit of a misnomer because all vertebrae, not just temnospondyl vertebrae, are actually derived from different pieces that all get put together to make kind of one cohesive part that does the function of a vertebra. And you might think of like all vertebrates have vertebrae of some kind. But they don't have all the parts necessarily. So I want to show you kind of what I mean by this. So most of what we find for temnospondyl vertebrae, at least that we've found, are these things called intercentra. So it's like this little cylinder of bone. It doesn't look like a whole lot. They're actually kind of disc-shaped, which is a little bit weird for a temnospondyl. Usually temnospondyl vertebrae are shaped like wedges, but these particular ones are known for having their disc-shaped vertebrae instead of like carved out like crescent moon shaped and wedged. So that's kind of interesting. So besides the centrum, which is kind of this bony core, just a cylinder that forms most of what we think of when you think of a backbone, we also have neural arches. So a neural arch forms around the spinal cord. This is a neural arch of a temnospondyl. Again, it's very small, so it might be hard to see. But I have some neural arches that I can show you from bigger animals as well. So there's that neural arch, forms around that spinal cord. You have them in your back as well. And this one is kind of cool. This is a vertebra from the tail of a temnospondyl. So we see our centrum. This one has a little bit more of a crescent moon shape, and it's a little bit more wedge-shaped like we see in most temnospondyls, unlike most of the ones we see at this quarry. But it also has this thing that we call a Hemolarch, or a chevron. So the Hemolarch, hemo refers to blood, and it surrounds the dorsal aorta that goes all the way down the tail in everything besides mammals, because mammals are weird. Just is what it is. And then we also have another vertebra here. This one is from just behind the skull, so we call this the atlas. It holds up the skull like Atlas holds up the world. Yeah, it's got a neural arch. It also has a rib stuck to it, because of course it does. Yeah, those are the temnospondyl vertebrae. We have the centrum, neural arches, and hemolarches. What you can see here on the table, this is the centrum from a sauropod dinosaur. It's considerably larger. And then this is part of the neural arch, and this big thing coming up is called the neural spine. And at the end of it, which I'll zoom in on this, is this big rough part, and that is for muscle attachment. Now, animals that need to support themselves on land have lots of muscle attachment coming off of their vertebrae. Very strong muscles to kind of hold everything up, especially in sauropods and even in large land mammals today, like this bison vertebra. So this is a bison vertebra from the middle of its back. It's one of the thoracic vertebrae. So it's got this big rough portion at the end of the neural spine. And here we have our centrum, this round cylinder structure, and there, that hole is where the spinal cord goes through. And then this is our neural arch. But it's all fused together, unlike what we see in the temnospondyls with their cut vertebrae. So, I hope that gives you a little bit of perspective on what a vertebra is. It's not just a single bone, it is a bunch of stuff all cobbled together to make a working structure, which is kind of awesome if you think about it. Weird that we ended up with, certain ones that we have today. So, I hope you enjoy the rest of your visit to the UW Geology Museum open house. Take care. I'll see you hopefully soon.